The Beauty of the Unknown. A conversation with Brian Cox on science, AI, and the mystery of existence in a recent wide-ranging discussion. Physicist Brian Cox explored the delicate balance between scientific certainty and the profound mysteries that drive human curiosity. From the symmetry of a snowflake to the unpredictable rise of artificial intelligence, Cox's reflections suggest that the most important part of science isn't just what we discover, but our willingness to admit what we do not yet understand. The power of I don't know. Cox draws inspiration for his latest live show, Emergence, from Johannes Kepler's 1609 work, The Six-Cornered Snowflake. Kepler, a giant of planetary motion, famously puzzled over why snowflakes possess six-sided symmetry, a question he couldn't answer with the tools of his time. For Cox, this admission of ignorance is radical and essential. He posits that science is defined by three distinct categories: the remarkable, things we currently understand; the unknown, the mysteries we are actively investigating; the unknowable, concepts that may lie forever beyond human grasp. This perspective shifts the focus of science from a mere collection of facts to a continuous philosophical pursuit of meaning. Frontiers of discovery. AI and quantum computing. When discussing the next decade of scientific advancement, Cox points toward two revolutionary but unpredictable fields: artificial intelligence and quantum computing. Artificial intelligence. Cox describes AI as a double-edged sword, an exciting leap forward that simultaneously presents potentially a problem. The core issue is its trajectory. We are developing a power that is rapidly outstripping our ability to predict its ultimate impact. Quantum computing. He notes a significant lack of consensus, even among experts. While some predict quantum utility within 5 years, others believe it may not be realized within a lifetime. This uncertainty highlights a broader trend in modern science. We are creating technologies so transformative that even the architects of these fields cannot agree on their timeline or final form. The search for life and the scale of the universe, one of Cox's most enduring questions, remains the search for extraterrestrial life. He notes that we are closer than ever to an answer, thanks to spacecraft missions currently en route to the moons of Jupiter, the James Webb Space Telescope, which can now analyze the atmospheres of distant exoplanets for biological signatures. This search is contextualized by the staggering scale of the cosmos. Cox highlights a profound shift in human perspective. In the 1920s, scientists were still debating if other galaxies even existed. Today, we know there are approximately 2 trillion galaxies in the observable universe alone. To Cox, the most astonishing fact isn't just the age of the universe, 13.8 billion years, but the fact that humanity has actually succeeded in measuring it. Reflections on culture and connection beyond the laboratory, Cox offered a candid look at his views on society and art. Social media. Once a utopian vision of global connectivity, Cox now views social media with skepticism. He notes that while it promised a healthy exchange of ideas, it has largely become a noisy environment defined by misinformation and political polarization. The evolution of music. Interestingly, Cox perceives a stagnation in musical innovation. He contrasts the massive stylistic shifts seen between the 1950s and the 1980s, from Frank Sinatra to Pink Floyd, with the relative lack of distinct evolution in music from the year 2000 onwards. The intersection of art and science. Rejecting the idea that music is strictly an art and science is strictly a discipline, Cox argues they are both human responses to the beauty and mystery of the world. Science is ultimately a response to the beauty of the world, and so is music. All human pursuits are a response to the beauty and mystery of the world. Conclusion. Brian Cox's insights remind us that science is not a static body of knowledge, but a dynamic, often uncertain journey. Whether exploring the vastness of 2 trillion galaxies or the complexities of AI, the true driver of progress remains our fascination with the unexplained.